Okay, pre-calculus, we're talking about determinants and multiplicative inverses of matrices. Okay, now in order to get the inverse of a matrix, you need to find the determinant. And you need to find the determinant, you need to understand what it is. Okay, so we've already talked about this in Algebra 2, but just to go over it real fast, here is a great little website, mathisfun.com. Alright. The determinant of a matrix is a special number that can be calculated from a square matrix. The matrix is an array made of numbers. The determinant is the matrix, is all this. The determinant tells us things about the matrix that are useful in system of linear equations, help us find the inverse of matrix, is useful in calculus, and more. Okay, and I especially know eigenvalues in linear equations. That is where it pops up. But for right now, we're just starting out with the basics of just finding it. Symbol, you're going to be using an absolute value form. Okay, so calculating a 2 by 2 matrix, really easy. You take the first diagonal, A times D, and then you subtract the second diagonal, which is B times C. Okay, alright, so something simple as this: 4, 6, 3, 8. 4 times 8 is 32, minus 6 times 3, which is 18, which is 14. So the determinant for this matrix is 14. A 3 by 3 matrix is a little bit more interesting. Okay, so I'm not going to focus too much on that. However, if we go back to here, to where you can actually use the matrix calculator to get it, you can find the determinant in your TI calculator by looking at the button DET, or you can just press this button. So the determinant of matrix A is going to be 84. Okay. Right, and there's some really funky stuff going on there, so just understand we're trying to find the determinant. Make sure you check it with a calculator to make sure you did everything correctly. Okay, or if you're really lazy, you can use the calculator itself, but just remember the calculator is not going to tell you everything. Okay, alright, but the determinant is hugely important, because in a multiplicative inverse, to get a multiplicative inverse of any matrix, alright, so A inverse is going to be equal to 1, and you're going to divide 1 by the determinant of A, so whatever the matrix A is, and you're going to times this by matrix A. That's how you get the actual inverse matrix. So that's what's happening on your calculator when you're actually calculating what it's going to be. So if I did inverse, what I'm doing is I'm in fact taking the determinant, dividing it into 1, and then I'm doing a little bit of magicalness in here, okay, and doing the inverse, alright, and just working with it. So it's really interesting how it works that way. Okay, you know what, no, I'm going to go back to the notation, because it's not just the matrix all set up. It's not just A. Okay, let me get rid of that. It is going to be a certain type of matrix, but it's going to be something a little bit different. Okay, what you're going to do is you're going to rearrange matrix A. Okay, so it depends on if it's a 2 by 2 or a 3 by 2, how you rearrange it. I'm not going to explain a 3 by 3 or 2 by 2, but I do know that if this matrix was, if the original matrix was 2, 5, -7, and 9, okay, the rearranging of it would be 9 and 2. So you'd switch the 9 and the 2, and then you would change that to a -5 and a +7. So that's just the rearrangement that I'm talking about, okay? Alright, but once you do that, the inverse is really easy. I'd highly recommend just use a calculator to just get it and just to make sure you know. Okay? Thank you guys very much, and have a great day. Bye.